Look up on a clear night and you'll see it. The moon. So familiar it barely registers. But what if it was never there? Not destroyed, not moved away, just never formed in the first place. No moon from day one. Tonight we're going to discover just how profoundly the moon has shaped everything about Earth, from its axial tilt, to its tides, to the origin of life itself, and what our planet would look like without it. The answer is a world so alien you might not recognize it as Earth at all. The moon didn't form alongside Earth in the normal way. The leading scientific theory, the giant impact hypothesis, proposes that about 4.5 billion years ago, a Mars-sized protoplanet called Theia collided with the early Earth. The collision was glancing rather than head-on, and the debris ejected into orbit around Earth gradually coalesced into the moon. This theory explains a lot: why the moon has almost no iron core. The iron of both objects merged into Earth's core during the impact. Why moon rocks have the same isotopic signature as Earth rocks, and why the moon is unusually large relative to Earth compared to other planet-moon systems. Our moon is not normal. It's a scar-turned satellite. The moon's most critical role, the one that most people never think about, is stabilizing Earth's axial tilt. Currently, Earth is tilted at 23.5 degrees relative to its orbital plane. This tilt gives us our seasons. It's been remarkably stable for hundreds of millions of years. And the moon is the reason. Without the moon's gravitational stabilizing influence, computer simulations show that Earth's axial tilt would vary chaotically, swinging between nearly 0 degrees and over 85 degrees over millions of years. At 85 degrees tilt, Earth would essentially be rotating on its side. The poles would point toward the sun for half the year. Climate swings would be extreme, glaciations followed by baking heat in the same locations, cycling over millions of years. Life as we know it requires relatively stable conditions over long periods to evolve complex forms. Simple bacteria can survive almost anything, but complex multicellular life, the kind that eventually produces animals, brains, and civilizations, requires stable enough environments for specialization to be advantageous. In a world with wildly swinging axial tilt, specialization is dangerous. An organism adapted to polar cold might find itself in equatorial heat within 1 million years. The evolutionary pressure favors generalism, simple, robust, adaptable organisms, not complexity. Without the moon's stabilizing influence, Earth might be a planet of bacteria and simple algae even today, 4 billion years after life first appeared. The moon drives Earth's tides, the twice-daily rise and fall of the oceans due to the moon's gravitational pull. Without the moon, tides would still exist, driven by the sun, but they'd be about 40% as powerful. This sounds like a minor change. It isn't. Tides are one of the most powerful geological and biological forces on Earth. They erode coastlines, circulate nutrients from deep water to shallow water, and, critically, create tidal pools. Tidal pools are the zones of rock exposed twice, daily, as the tide goes out. Many biologists believe that tidal pools were the evolutionary cradles where the transition from ocean life to land life first occurred. Without strong tides, without tidal pools, the colonization of land might never have happened. Here's something most people don't know. The moon is slowing Earth's rotation. Tidal friction between the moon's gravity and Earth's oceans transfers rotational energy from Earth to the moon, gradually slowing our spin. 4 billion years ago, an Earth day was only about 6 hours long. Over billions of years, the moon has lengthened our day to 24 hours, and is still lengthening it by about 1.4 milliseconds per century. Without the moon, Earth would still be spinning near its original fast rate. A 6 to 10 hour day would dramatically change atmospheric circulation patterns, creating much faster, more violent winds globally. Weather systems would be more intense. The stable, moderate climate zones that allowed agricultural civilizations to emerge simply might not exist. One of the most intriguing theories connecting the moon to life involves the chemistry of the early Earth. Some origin of life researchers propose that the RNA world, the first self-replicating molecules, could have emerged in tidal pools. The scenario works like this. Complex organic molecules concentrate in tidal pools when the tide goes out. They react with each other. When the tide comes in, the reactions are diluted and quenched. This wet-dry cycling, repeated twice daily for millions of years, could have driven the polymerization of RNA, the first molecules capable of both storing genetic information and catalyzing chemical reactions. Without the moon and its strong tides, this cycling might not occur with sufficient intensity. Life might have found another way, but this particular pathway might have been closed. Let's assemble the moonless Earth picture. The axial tilt is unstable, cycling between near zero and extreme values over millions of years. The current tilt might be close to zero, meaning almost no seasons, with the equator permanently hot and the poles permanently cold, with little temperature variation through the year. The day is shorter, perhaps 10 to 15 hours. Winds are stronger and more chaotic. Tides are weak, coastlines are calmer. Complex animal life may never have evolved. Or if it did, it might be limited to forms that could tolerate rapid environmental change. Intelligent life? Probably not. We are, in a very real sense, a species that exists because a random protoplanet crashed into Earth at exactly the right angle 4.5 billion years ago. Here's what makes the moon's formation more remarkable the more you think about it. The giant impact that created it had to be just right. Too large an impactor and Earth would have been destroyed entirely. Too small and the debris wouldn't coalesce into a large enough moon to stabilize our tilt. Too head-on, and the result would have been a merged planet with no satellite. The angle, the size, the timing, all had to fall within a narrow range to produce the moon as we have it. Some scientists estimate the probability of this specific outcome at less than 10%. We exist because of an incredibly precise cosmic accident 4.5 billion years ago. The moon isn't just our satellite, it's the reason we're here. Every time I research one of these topics, I come away with the same feeling, that existence is extraordinarily improbable, and somehow here we are anyway. The universe had to get so many things exactly right for you to be sitting here watching this video. That's worth thinking about. Subscribe for more videos that put the scale of things in perspective. New deep dive every week. See you in the next one.